Rutgers engineers have embedded high-performance electrical circuits inside 3D printed plastics, which could lead to smaller and versatile drones and better performing small satellites, biomedical implants, and smart structures. They used the pulses of high energy light to fuse tiny silver wires, resulting in circuits that conduct 10 times more electricity than the state of the art, according to a study in the journal Additive Manufacturing. By increasing conductivity tenfold, the engineers can reduce energy use, extend the life of devices, and increase their performance. This innovation shows considerable promise for developing an integrated unit using 3D printing and intense pulses of light to fuse silver nanoparticles for electronics. Embedding electrical interconnections inside 3D printed structures made of polymers or plastics can create new paradigms for devices that are smaller and more energy efficient. Such devices could include CubeSats, that is small satellites, drones, transmitters, light and motion sensors, and global positioning systems. Such interconnections are also often used in antennas, pressure sensors, electrical coils, and electrical grids for electromagnetic shielding. The engineers used high-tech intense pulsed light sintering, featuring high-energy light from a xenon lamp to fuse long, thin rods of silver called nanowires. Nanomaterials are measured in nanometers. A nanometer is a millionth of a millimeter, about 100,000 times thinner than a human hair. Fused silver nanoparticles are already used to conduct electricity in devices such as solar cells, displays, and radio frequency identification (RFID) tags.